Evo, došli smo do našeg zadnjeg predavanja u ovim našim danima Orisa. Naš sljedeći predavač nije arhitekt, on je inženjer. On dolazi iz Slovenije, rođen je u Ljubljani, studirao je u Mariboru. Maybe I can shift in English, right? I should shift in English. So our latest lecturer tonight is an engineer. He's not an architect. He's coming from Slovenia. He was born in Ljubljana. He studied in Maribor, and where he became a specialist in engineering, specifically in seismic engineering. And he has designed all his career bridges and ambitious constructions. And he has designed bridges in Slovenia, in Croatia, in Turkey, in Israel, Montenegro, if I'm right. And as far as I know, he is very much interested not only in these engineering performances of those constructions, but also in their aesthetic values, in their ambiental values. His name is Marjan Pipenbaher, and I welcome you here. He is the designer and the chief engineer of the Pedestrian Bridge. This is the big thing in Croatia in these years. It was connected last summer. We all believe and strongly hope it's going to be fully functional this summer. So we are really curious to hear from you how it's going to look like, how it's going to function, how the traffic is going to function, and how it's going to fit into the ambient.
Hello to everyone. We are finally in. Okay, we will complete this session, with the engineering issues. For designing of such a bridge, you must have some experience, not some, but quite a lot of experience in stay cable bridge design, long span bridge design, earthquake engineering, fluid dynamic analysis, and paleostratus ranking in such a bridge. We should be aware, what is our knowledge, and that we have to construct more and more bridges, not to construct walls, It is also important that we understand, that we do or construct as simple as possible, as all in life, but not simple as some politicians or other people think, This is also a very powerful statement, from Einstein, from genius, It's not that I'm so smart. It's just that I stay with the problem longer, It's very good. About the less is more, più di meno, mit wenig mehr, it is also very important. Exupéry wrote very nice statements about this issue, What is the perfection, What is the perfection? He was constructor of the airplanes, also the writer. And you can see, development of the airplanes from the First War to the Second War, Spitfire and the stealth structure, The perfection is, when you cannot move anything or remove something more. The engineering, it is old issue, And it was always connected. It was always master builder, And from Roman time, Vittorius wrote, his book, The Architectura. He discussed about functionality, aesthetic, and firmness. This means the stability of the structures. Then Palladio added ornamented, that the bridge should be well-aligned, comfortable, durable, and also that we should take care about the architectural design of the bridge. Till end of 17th century, there was master builder. The builder was the architect, was the engineer, was the constructor, and what was very important, that the designer or the master builder should exactly know how the bridge or the structure will be constructed. Anyway, bridge contribute a lot to our society, bringing the growth, integrated people. but it is one problem, that segregation which was done in the end of 20th century, where the building process was separated with the École de Polytechnique and École de Beaux-Arts, to the architecture and to the engineering, and that leads to the specialization. I just want to show you on 3-4 my project, how I understand, the design of the bridge, architectural design. For me, it's very important. I like it, I like study a lot. I like forms. I like nice design. So large bridges, that means large viaducts, we should take care, that the structure should be already the architecture, so that the architecture is developed through the structural design. That is normal, that you can realize, that you can understand, the flow of the forces. This is the Črni-Kal viaduct in Slovenia. We won the competition, then constructed. We have just one 95-meter tall pier, and that is very, very nice. It looks very nice in this landscape. Then I got a mission, under the Črni-Kal, there will be 2 high-speed railway viaducts, And we have already huge problems during designing the Črni-Kal, and after that we have to add 2 additional viaducts. And that was quite challenging, And my idea was that these viaducts, railway viaducts, should be designed like a high-speed train who is passing the valley, and it will look like this. Then is Pelješac Bridge, which is really, from structural point of view and construction point of view, really demanding construction, foundation, earthquake, wind, all this issue. And it is also very important how to fit to the landscape, the structure of the Pelješac should not be dominated over this very, very nice landscape, and we can just add a structure which linearly passes this beautiful bay. Okay, that was the Millennium Bridge in Montenegro. When Montenegro declared the independence, they wanted to have the bridge as a statue of the modern Montenegro. Okay, we did it. It is bridge, it is statue, and they like it. Then are pedestrian and cycle bridge, which are more filigramic bridge. This is the bridge over the Drava River in Ptuj, where you should also take care more about the equipment on the bridge. These bridges are not dedicated to the traffic. The drivers don't run over the bridge with 180 or 80 kilometers per hour, but the people walk through the bridge, over the bridge, and they enjoy, and it's very important. What is very important? Each bridge is unique, and it should be studied individually. This is Budapest Bridge. We were invited to the international design competition. 18 the best or the well-known offices from all around the world were invited, and we were also got the purchase award on this competition. Another competition which was also awarded competition was competition for the Danube Bridge in Linz. We got the second. We awarded with the second prize. This bridge. It is. I told. For me, it was this bridge like a Ferrari, and I don't know. Mark Mirmar won this competition with quite like more as a Chinese design bridge, Bridge designer must consider, visual equality as a fundamental criteria, as like the stability and also the safety. This is the bridge concept. This is the bidding design. I prepared one conceptual design or bidding design for the Amudarya Bridge in Turkmenistan. That was done for the presentation was done, that we presented to the president, But after that, this French-Croatian joint venture, was not strong enough to push out, Ukraine contractor. And of course, Pedestrian Bridge, I like it very much. I like this landscape. I like Croatia. And it is, I have to point out, the designers can achieve really outstanding visual quality in the bridge design without compromising, structural integrity or construction cost. That's very, very important. You don't need to add so much. The design for the bridges design doesn't cost so much, just a little bit, and it is worth to do these efforts. For bridges and for other structures, I always discussing, or for me is the bridge builder, which is engineer and architect. I cooperate with a lot of architects, we also find a way, but a lot of bridges was designed only by me, like Amudarya, like in Koroshki Most, like all bridges in Turkey, cable stay bridges over Euphrates River, also the Pedestrian Bridge. And what is important and what can we learn from history, It is important, that the bridge builder, that means designer, should have enough experience. Also, for bridges, it's very, very important to have technological knowledge, because the designer is first who should know how the bridge will be constructed. It is also important that he has the feeling, architectural feeling, and on the other side, you should have the client who will support idea, who have to pay also the investment, and then we can get, the buildings which can outgrow the time component and become part of the cultural heritage. But always is the main issue, Symmetry, natural rhythm, harmonious proportion, like always in music, always balance and form purity. And just like the true love, well, architectural and structural design bridges, they can last a long time, surviving. It's very important, all styles and all fashions. And one of such bridges, Aqueduct Le Pont de Gard, old over 2,000 years. And I have to show you a very interesting concept of the bridge, which was prepared by Faustus Verantius 400 years ago. And in the meantime, the technology, design, computers, all this contribute a lot to development of the bridge. In the meantime, also, the man landed on the moon. We have free space station. And in the meantime, also such bridges were constructed. It's amazing, the Turkey has now 2 world records, not the Chinese anymore. 3 years ago, the Chinese have all the world records about the long span bridges. And for stay cable bridges, from 10 of them, 7 of them were constructed in China, 1 in Korea, one in Europe, and 1 in Japan. And this is Sultan Selim Bridge, is just following this idea, 1400 years old idea about the hybrid bridge concept. And we should not forget, it is all around the world where I was working, the bridges are always, the point or subject of political, are very interesting for all politicians and all for politicians' options, I also want to point out one issue, that's my experience from the last competition for the Danube Bridge in Budapest. Budapest, it is very nice. I liked it so much. It has a lot of bridges. But it is interesting, all old bridges are very nice, bridges which were constructed recently, I don't like them, they are they have too engineer approach, without any, feeling of for the architecture, This is competition solution, first awarded Van de Berkel, then the second Zaha Hadid, and the third Lavin architect. It's quite, and this is our solution. We called our solution not revolution, evolution, We didn't have any full renewed architect, We just have three young Hungarian architects, who never designed the bridge, We just need, the good, nice renderings and also discussion about the fitting to the bridge to the city area. Urbanism in architecture, all these lessons, as you heard, urbanism is the main issue, in architecture, So you have to really understand, the genius loci, the location, to find the proper approach. This is also very important for the bridges, that you understand the location of the bridge, topographic, geology, and all these issues. The problem is also, that quite a famous offices, architecture and structural engineering offices, gave such a proposal, That means that it's only important that is not déjà vu, and it is negation of all structural logic. And I really like Picasso, When he was young, he did perfect portrait, like Renaissance painters, Botticelli or Leonardo. After that, he find his way. And even for Picasso, who was somehow like Dali, and Font Terrible, even he stated, that world is becoming more and more decadent, and you can see on the right, the last Picasso's picture, that's auto-portrait before he died. Fashion and also the structures becoming more and more decadent, That's life, without, it is just important, that is something new, doesn't matter, without respect any normalism. Okay, but we are living on the earth, in this space. There is earth, blue planet, We have to like it, and we have a good luck, that we are living. Okay, I live in Slovenia. It's about 600 kilometers apart from Pelješac, which is really, really heaven, on the earth. These are the picture from the Pelješac. And also to have chance, to design such a bridge in such a nice area. Okay, about kids, how they thinking about the bridge. As I explained before, just to show what is the complexity of such designing and constructing such a bridge. It is ranking, among the 5 large span bridges recently constructed in Europe, Rio and Tyrion, Cadiz, Spain, Mersey Gateway Bridge, and Newford Bridge. This is Pelješac. During the construction, also such figures or such movies can be done. The client, it's not necessary to explain. Exactly. Who is the client, who is the designer. I just want to point out, that CRBC did really a perfect job. They did a lot of effort, It's not easy, to come to Europe, and to start to construct. I was several times in such a situation, in Turkey first time, in Israel, in Algeria, in Germany, in Austria, in Croatia also, in Montenegro, in Serbia. It's not easy, you have to come, you have to prove that you're able to do it and so on. Okay, these are the main characteristics of the bridge. It is really the huge structure, and this is the responsibility, These are really the large structures which are fitting or constructing in the area. That's 70,000 cubic meters of concrete, 70,000 tons of steel structure and so on, And it will stay there, We will not be alive anymore, They will be there, If the maintenance will be okay, it will stay there, I don't know, without any problems, 200 years, if there will not be problems with the functionality of the bridge, that the technology of the trailing will totally change. Bridge is located in really high sensitive and protected area of Mali Stone, It is completely protected by Natura. And all these discussions from Bosnia, that they lost the passage, they are not able to enter to the Neum and so on, this is worthless, We have the navigation span 200 times 55 meters, This is the navigation span which is prescribed for the largest port in Europe. For instance, Hong Kong has 400 times 68 meters, Hamburg 200 times 55 meters. And what are the specific of the location? Of course, first problem or specific is geology. The sea depth is constantly 27 meters. Then we have soft clays, really soft clays, in the thickness 40 to up to 60 meters. After that, medium hard and hard clays, and then we have weathered rock and solid rocks. That's why the piles which were driven are up to 130 meters long. Another specific is seismicity of the location. This is really the highest seismicity in Croatia. This area also to the Albania, through the Montenegro, and it is acceleration 0.34 G. Even during the earthquake in Budva, there were acceleration over 0.4 G. Then, of course, there is wind, Bora wind, over 150 kilometers. We had this wind during the construction. The bridges are the most sensitive about the stability during the construction. And of course, south wind, About the project preparation, we are involved in this project 9 years, from the beginning of 2013, before already our colleagues who also cooperate with us on this bridge, Gordana Hrelja and Nijas Mekanovic, they were already involved before with Professor Radic. Also, Professor Radic cooperate in the design in this bridge. And what is the basic idea? The basic idea is always, Genius Lots, peninsula landscape motif, that's countless, hills. It's very, very nice. I like it so much, And this is the landscape motif from the sea. And after that, idea comes, just comes. That's the best time, when that's meant to starting with design, to starting with ideas, to proving with ideas, and try to understand, what can you fit, There should not be any large bridge, with tall pylons and so on, to be dominant over this beautiful nature. So, of course, during the design, we did a lot of analysis, optimization. We have to do it to prove the client, what is the way, because for the client, It is on the first place, it is how it will cost. Then the client already forget about the durability and life cycle cost that in the next 100 years or 130 years, it will have to invest, I don't know, half of the price of the new bridge. And what is also very, very, for me and also for client important to know is positioning of the bridge, considering, the natural constraints and landscape architecture. Of course, after that follow, in the same time, rhythm of supports, proportion between the structures, between the pylons, and also, final design of the bridge. This is the view of the bridge, longitudinal section, plain bridge. It is very, very peacefully designed, very light. It is quite transparent, and also symmetric in the bay area with 5 main spans, 285 meters. It is also designed very, very inventively, We don't have bearings, we don't have any damping device, under the pylons. So that's mean almost 2,000 meters. That means center part of the bridge is without the bearing. What is very important, for the stability during the construction and the reducing the cost of the maintenance of the bearing. That's mean maintenance and replacing of the bearings. Because the bearings, whatever you do, even you take the best bearings from Maurer and you are asking, the quality for the German railroad, they cannot guarantee more than 40 years, That's a bridge superstructure concept. It is steel superstructure, free cell with orthotropic steel deck. The superstructure should be as light as possible, so it is impossible, to be concrete structure or the composite structure. This is superstructure concept in the approach span at the top, various continuous beam, with the spans 108 meters. After that, we have 200 meters, and then we have 5 spans, 285 meters. On the bridge will be also installed the wind barrier. I have a lot of experience, with wind barrier. I started this in 2002 on the Črnikal viaduct, which I showed before. And the request of the client was that the traffic should never be interrupted or stopped over a bridge due to the Bora wind, because Bora is very, very also strong. I recently also designed the wind protection on 11 viaducts from Postojna to Ajdovščina, and there we have Bora peaks up to 200 or over 220, even over 220 kilometer per hour. So this will be very, very good. Just to show what the pylon, it is interesting that half of the bridge, it is under the water. That's the length of the pylons. The length of the piles are 40 to 100, so almost 130 meters. So on the pylons in the middle, that's the pylon 7 and 8. There are the piles. The piles are 128 to 129 meter long. These are the piers. And what was very, very problematic, and where we spent really, really a lot of time is how to found the bridge. After that, we analyzed it to have the skew piles, to have just vertical piles, and these are the final. We decided to just have vertical piles, to simplify construction, to reduce the risk. It is very, very important to do during the design the risk study, not just how the bridge costs, to do also the risk study. What are the risks? It can be something can be cheap, but the risks are very high. It's very important that parallel with the design, we also do and thinking, what are the risks during the construction and what are the consequences on the delaying of the construction and the cost of the construction if something happens. Just short overview about the static and dynamic analysis. For such bridges, we always two parallel analyses with two teams, inside the office. Always, we don't want to have any serious complaints after that, and discussion with the Czech engineers. The Czech engineer for final design was Kovy. It's this famous company, it's constructing and have consulting all around the world, over 6,000 engineers. And for detail design, it is Ramboll, also even larger than Kovy, and we didn't have any complaints, so we didn't change a lot, or almost nothing. That's very, very important, because you can lose a lot of time. I'm now Czech engineer for also one very large stake cable bridge in Turkey. They intend to construct the channel between the Black Sea and the Mediterranean Sea, and there is a bridge. We are not competitive. We lost this job, but the client asked, General Highway Director wanted that I am the Czech engineer for this bridge, and I know what does it mean if the project is not done, how much time you lost for this. The loads which are decisive for Pelotas Bridge, of course, is earthquake, wind load, ship impact, and we have still superstructure with steel plate. This means it is fatigue. It is also very important. Of course, we did first preliminary analysis, after that, detailed analysis. And what was also important, such bridge with such foundation, in soft clays, you cannot do linear analysis, So the bridge was designed, was analyzed, a totally non-linearity, considering, soil structure interaction. That means interaction of the soil and the bridge, together. That's forming the curve, analyzing of the bearing capacity. One important issue is the wind load, especially the wind load, during the construction. Bridges are very, very sensitive, during the construction, because they are not connected. After that, when the bridges are constructed, they are quite stable, The stability can be engaged, due to the, foundation issues and so on, but generally, then it's okay. It was also important that we check the stability and check what is the with traffic. This is also very important, that we ensure the stability of the vehicles. So for the personal, that's mean for just for personal cars, there will be no restriction. Also for the trains, perhaps some restriction for the very, very, double-decker buses, which are very, very light and quite high, but up to 130 kilometer, 140 kilometer, there will be not a problem with the stopping, because we have to do like is usually with such a bridges, with such a span, that we did the wind tunnel test, that was done in Copenhagen, in Denmark, by Force Technology. First is section model test, and if it's all okay, then follow the full bridge model test. And I can show you now. This is the section. This is the pylon test. The bridge during the construction. This is in reality, about 66 meter per second. That's about 240 kilometers per hour. So these bridges, steel bridges are not so stiff, so stiff as the concrete bridges, or stone bridges. They always vibrate. They always vibrate. It's just the issue that the vibration should be in the prescribed limits. So then is earthquake. This is earthquake seismic hazard map of the Europe. You can see where is Croatia, where is Slovenia. We also have problems with earthquake in Slovenia, and I don't know what will be if such earthquake as was in Croatia. It would happen. In Ljubljana. What it would be, really the huge problem. The seismicity, and we did also nonlinear seismic time history analysis. we got from the university from Zagreb for Institute for the Geology department, we got the accelegrams for the earthquakes, with the magnitude from 6 to 7.5, with epicenter 5 kilometer to 150 kilometer apart, and in the depth of 10 kilometer. Always is problem. What is the real damping? This is not so easy. So at the end you have to sacrifice some frequencies. But okay, it can be done. Theoretically it's not clear, but when you come to the practical problem, it becomes a problem. But it can be done, and it was done. And here you can see, the bridge during the earthquake magnitude 7, for instance. The top of the pylon will move between 60 to 80 centimeter. That's about, I don't know, 100. If we have the bridge 100 meter over the sea, and then it's about 30 meter. It's 200, the height of the bridge divided by 200. That's okay. Of course, the bridge is designed that we don't allow any damages. This is very important. All this issue about the reductions factors and so on. They can be applied in the buildings. But also in the buildings, I was several times designed also the tall buildings. If you consider and estimating the damage criteria. What happened? I designed in Ljubljana one with Professor Podreka, one residential. It is it's business house with 70 meter, 80 meter high, and the structure cost were 50 million euro, but facade was 10 million euro. So we have to be very careful. What is the story drift, and what can happen, and how many, what will be damaged, during the earthquake. So this is very, very important issue, not just stability, We also paid attention for this issue, like the contact between the concrete structure and between the steel structure, because we designed it quite inventive. It is a hybrid structure, so we don't have any bearings under the pylons, and this is quite a delicate contact between the steel structure and between the concrete structure. That was all designed and so on. This is about design. Another issue is design life monitoring and maintenance of the bridge. This is also very, very important issue, and the client and designer, all of us should take care about this. The bridges which are 2,000 years old, these bridges we are now constructing, they cannot last so long. They are also not designed, in a way like arch bridges with concretum, with very, very thin and mainly in the stone, So it's very, very important that the client understands, that something is construction cost, something is, service life of the bridge, what should be done during the service of the bridge, how to maintain it, how to repair it. And also we have to reconsider what will be the reconstruction and also the replacement cost. I'm now designing 2 highway bridges in Slovenia. This will be the first time, that 2 bridges, 2 viaducts, which one is 450 meter long and one is in Ljubljana, 300 meter long, They are so damaged, that it is crazy, to invest additional, I don't know, 1,500 euro per square meter. So we have it, and the client make a decision, made a decision that the bridge will be replaced with the new structures, and this is really problematic. We have in Ljubljana 70,000 vehicles per day. You know, that's the main issue. You know, what the client care. What were the special measures for increasing the durability of the Pedestrian bridge? You know, the first was we don't have any sharp edges. You know, that's the first. Then you used ultra high strength concrete. You know, C50, 60, pylon 70, 85. Okay, we also need this strength because of the forces, because of the loading. We increased the protection thickness. Thickness of protection layers, you know. Then we additionally reinforced, you know, this protection layer with the stainless steel bars. Also, we used the protecting coats. It is very important, you know, how to cast the mass concrete. You know, the pile cap has dimensions 29 times 23, and the thickness is 5 meters. You know, and the designer and also the contractor should take care, you know, how such a mass concrete will be constructed, you know, and what are the consequences that it not cracks. You know, these are very important issues. These are all issues about the bridge management. We prepared in final design stage, you know, all these reports about the bridge managing, monitoring and maintenance, and now during the detail design it will also be prepared detail report about how the bridge should be, you know, inspected and how should be done and maintained during the service, you know. There is a lot of recommendation, and what is also important, we also install on the bridge complete monitoring system, you know, that we are able to analyze the short and long-term structure behavior, that we can early register the potential damages, that the client can effective planning, you know, the maintenance work, assessment, and increasing, of course, we are increasing safety. This is concept. Now it's already done, it is already completed and installed, you know, the complete bridge monitoring system. That's mean over 200 fiber optic sensors are installed on the corner piles, practically on all supports, then on the piers, on the pylons. Then we have accelerometers, you know, on the pile caps and the structure, top of pylons. Top of the pylons are also GPS stations, you know, that we have through the satellite, you know, direct information in time what is the formation of the pylon. There are 2 anemometers, one for measuring Bora wind, one for measuring south wind, and also 2 seismographs on each side, you know, because it is very important, you know, that during the earthquake with the magnitude, I don't know, over 7, you know, we should know, you know, what was the real acceleration, what is the spectrum of this, that we can really reanalyze the bridge and see, you know, but it should not be damaged in such a case. You know. Important issue is also the bridge maintenance and checks. That's mean daily inspection, seasonal inspection, every 4 years, and after exception event like earthquake, strong wind, fire, and ship impacts, and so on. And we also prepare the table for the client to warn him, you know, what he will have, what he have to do, you know, during the service, and what will be the activity, you know. I don't know when to replace the anti-corrosion protection of the steel structure, when to replace the pavement, you know, when to replace the asphalt, and so on. That thinking a little bit about this issue, and just to show a little bit, you know, if the bridge will be well maintained, you know, and that somebody really will take care about him, you know, the bridge even after 100 years should be, like untouchable. But another issue is if you don't take care or you have poor maintenance work. And now we'll go, this is also what will be also very interesting for you, how the bridge was constructed, About the site organization, production of piles, pile cap construction, pier construction, pylon construction, superstructure, execution of specific works, The design is usually not for the bridges, also for the buildings, when you complete design, when you send the drawings and digital version, for designer, this is not the stopping work, the real works, start, also during the construction, because you have to take care about the method statement, you have to do it with the construction company. You design the bridge for the in-kuni contractor, So after that, there are some adaptation, there are some proposal, how he will do it. This is signing the contract in Dubrovnik, and this was the construction site, in the 2018 on the mainland site, on the Pedestrian site, and after 1 year, when they installed the CRBC already, installed the CRB offices and also the concrete plant and all this issue, what is necessary for the construction of the bridge, Also, the Chinese take care, that is all done. Of course, the main issue is, technology. What you have, here is the main issue about how the main issue is how the bridge will be constructed. What is the availability of the technology by the company, and they delivered, with one road, eight floating barges, also with floating crane with capacity 1,000 tons, which is quite rare, in the world. There's such a floating crane. They have Korean contractors, Korean, Japanese, and also Chinese. In Europe, that's mainly about up to 500 tons and so on. And this is, how it was started, and here is the driving machine for the driving of the pile caps, and production. We have to see how the pile caps were done. In the final design, we're thinking, okay, if this will be constructed by the European companies, we have to do it that they can be competitive. So we will take into the consider that the piles will be done in two pieces. But the Chinese, they said, okay, we are able to do piles up to 130 meters in one piece, and that was done, And here they gain at least 2 months, because the welding of the 164 piles diameter of 2 meters with a thickness 40 millimeter, this will be at least 3 days, per pile, without complaining, about the cracks, about the bubbles, and about the weld quality.
Construction of a pile foundation. The S3 to S12 piers are located
we did some
in the
presentation,
Steel
and
pipe
this
piles
is
with the
now the
diameters
CRBC
of
presentation after the
1,100 millimeters
construction.
and 2,000 millimeters are used as a foundation.
The piles are diameter
the S3,
on the approach
S4.
on the approach area 1.8 meter, but for the pylons there are 2 meter, and the thickness 40 to 60 millimeter. And here is clearly shown how the piles were delivered and how they were installed and all this issue.
Through driving hull piles. First, the steel piles for central piers S7 and S8 are driven. The pile driving process is
it's unbelievable, you know, how this Chinese captain, you know, how he manipulated, you know, because this floating barge, you know, it doesn't have any machines, you know, so it's just moving, you know, through the whittles, and with 2 or 3 iterations, he exactly fixed the barge, you know, and it was quite effective, and really it's really amazing, you know. And here again, that's reality, you know, delivery of the piles and pile driving. We also use the bubble curtain, you know, to protect the fish, you know. Okay, it can be effective. But that was also a request of for the protection, you know, for the fish and so on. I don't have time so much. We will go on. These are a few pictures, you know, from the pile construction. This is also the RCD. It is RCD because when the piles are driven, you know, we have to clean up the upper 40 meter, and up the upper 40 meter of the pylon piles are filled with concrete. That's mean installed reinforcement filled with concrete, and this upper 40 meter is acting as a composite cross sections because there are so high loading. And on the approach bridge, pier number 2, 2, 3, and the pylon 10, 11, 12, there is very short or very thin layer, you know, of hard clay. So we have to do the buried piles. That means we have to driven the piles, and after that we have to clean up 80 meter of pile and do additional drilling 8 to 10 meter in the solid rock, you know, that we assure the required bending, axial bearing capacity. One very important issue is, you know, what are the real bearing capacity of piles, you know, and when we drawing piles, you know, through the soft clays, you know, there is well-known phenomena of setup effect, you know, because the clays are saturated, you know, with water, and there are pore pressure, and this change in the pore pressure, you know, it has quite amazing effect. And during the installation of the piles, you know, it is fall, you know, really very low, and so if the initial bearing capacity of the pile at the pit was, I don't know, 10 meganewtons, you know, after 1 hour or after 3 days was already 40 meganewton, you know, and after 90 days, you know, it was between 70 to 100 meganewton, and the largest force which we have, it's about 40 meganewton per pile. So we have required bearing capacity of the pile, you know. We also test the piles for the lateral resistance, because our analyses are nonlinear, you know, and we also check, you know, what is the real behavior, what is the real nonlinearity, and we find out, you know, that we are quite close. That's about the difference, 10%. You know, it's very good for such a terrain and for such circumstances. Pile construction, it is not easy, you know, to construct offshore. No? It is not easy. You have to do all from the sea, you know, and we proposed, you know, to do the shell concrete formwork, and we also have in the tender design that the client, the contractor can also propose, I don't know, to use the steel formwork, and as did the Chinese. And here is
pile cap construction.
just to show how the pile caps were constructed. This is not simple procedure, And construction of such bridge, it takes three years, It took 3 years. And all these years, we were daily in contact with the site, contact with the site engineers, with the contractor, and this is very important, when we are at least once per month, for a few days on the site, or even more, 2 days, two times, that we have the meetings, that we solve all issues, We have to approve also all the method statements. That's very important. This was also very important. That was in tender design, that the main designer should approve all the construction erection methods. So that's the best way, to protect the client and to take care about the high quality of the construction.
Sealing concrete is poured. The lowering platform is removed. Inner supports are installed.
This is real technology, and for instance, if the Chinese install 37 or 34,000 tons of steel structure in the superstructure, they use additionally 9,000 tons of steel structure, for construct the pile caps and construct the superstructure.
Their height are
It's quite a lot,
plus 1.5 meter, plus 2 meters. The largest costing amount is 1,000.
And we have all this time, we have good cooperation, and they followed, the instruction of the main designer, and that is also very good. And we also try maximally, of course, help them that the bridge will be constructed on the high quality level. These are pictures, during the construction. A lot of work, really a lot of work, demanding. You use the hydraulic for lowering the complete, scaffolding, with the concrete plate, with the side steel plates, and this is also the cathodic protection. The construction of the piers is nothing special, self-climbing formwork. It just have to point out, it is highly reinforcement. These piers, 3 to 3.5%, that's a lot. So we have strictly the couplers, of the pylon.
The support bracket is installed while the below pylon pier is constructed. When the below pylon pier is finished, first the
hydraulic formwork,
positioned and secured.
Then two first steel segments were installed, by floating crane. Then was casted the connecting segment. And also, it is also important to know that we stress this part of the concrete structure so that we don't have decompression, even by earthquake load, so that we don't have, any damages or crack during the large
The bridge
earthquake.
deck crane is also set up after the pylon construction is completed.
That's after that how it was done, in also with the pictures. Also, this steel, reinforcing steel, was installed in China. It was installed in China because it was impossible to install it after that, This pre-stressing of the structure, pylon construction. Pylon construction also, like it is the solid concrete section, 2.5 times 5. Okay, I have. Then just to show you, just manufacturing of the steel structure. To go through, a lot of work was done. 800-ton steel segments. all this testing, corrosion protection, shipping, 7 shipping was done, installation of the structure, procedure, like starting plane, you know, when you're installing this, installation of segments, how to do it. We'll go further, we don't have time. We'll go also further. Installation of stay cables, quite demanding, you know. What one important issue, you know, we stress the stay cables only one time, you know. That's very good, you know. It's very difficult, you know. Otherwise, you know, it should be stressed once again, you know, that you get the final alignment, you know. And what is also very difficult and also very demanding, it is installation of the connection segment. You don't have time, you know, but this installation takes 30 hours, you know, so we have to wait, you know, up to near mid of the night. And also this analysis with camber control are very important. But at the end, you know, it is always teams work, you know, teams work between the Chinese, between the engineers. This is our team. Also team with colleagues from the university, Zhang Dong. When he came and started to construct the bridge, he was 34 years old, you know, very young, you know. So we have to take care a lot about this, you know. And we prepared for the end the poster, you know, which is analog, you know, a little bit retro, you know, if you remember, for posters for Coca-Cola or for Ora, you know, it's something like this. Okay, thank you for your attention.